Hello everyone. In this section, we'll be looking at how to create various functions in Solidity. As we know, we have declared variables and assigned some values to the variables already. Now, we are going to use the same file to create the functions. As you know, functions are used to manipulate the variables, do something with the variables like integers, strings, booleans that we have created already. Let's get into it to understand more about how to create these. Now, a function in Solidity starts with the keyword called as function, and then you give a function name. Let me give a function called as set sum maybe, and then you start opening a bracket and closing this bracket. After this, you also give the visibility specifier like public, external, internal, private, etc. So let me do this as a public function, and then to write the body of the function, you open a bracket and then close the bracket. These will be flower brackets, and all your function body, the logic of your business or the app, goes inside this function body. Now, the function name can be anything, but it should represent what you are trying to do within the function most of the time. And then the visibility specifier can either be chosen as public, private, internal, external, depending on your use case. There are more keywords that can be given in the function declaration. Remember, this set of things is called as the function declaration, and this is called as the function implementation or the function body. Now, to set the sum and call one of the variables and do something with the variable, let's do an addition. Let us say that we have three numbers here, integer 8 and 16. So let me create another two integer variables, integer temp1 and integer temp2. Also, I need a integer sum variable. Let these be public variables. And let's temp1 be 10 and temp2 let it be 20. What I want to do in this function is to add temp1 and temp2, assign it to the sum variable. So when I want to do that, I can just say sum is equal to temp1 plus temp2. What this is going to do is access these variables values, temp1 is equal to 10 and temp2 is 20, and add it to the sum variable. Let's look at how this works, how to access this function and test the function in Remix deployment. Once I go to this deploy function, I can see that JavaScript VM and all of the other things which we discussed in the variables itself, and we have multiple accounts as well. So let's deploy this, and once it is deployed, we can access the entire contract here, and as you can see, all the variables are listed which are public. Now temp1 is 10 and temp2 is 20 as we declared. Sum will be 0 because for an integer the default is 0. When I call set sum, it should do 10 plus 20 added to the sum variable. So once I call this set sum, you can see that the transaction is complete here. In the logs, you'll get access to all the logs that are happening in the smart contract. Whether your transaction is complete, all of your returns and all of these things will come in the log section. So since the transaction is complete, let's go check the sum now. It should be 30 and it is 30 as we expected. So that is how you write a simple function to set the values to a variable and manipulate existing variables. Now, we can do something more to it as well. Any function also can get an argument from the user. What is an argument? An argument is something that you get as an input from the user while executing the function. Now, let me give two integers, integer underscore a and integer underscore b. These underscores are not mandatory for arguments. You can just name it a, but it is a common practice for all the Solidity developers to use an underscore before the arguments. If you want to do, let's say, assign this underscore a to a variable called as a, you can easily match with that, and that's the reason we use an underscore. Here, what I can do is integer underscore a and underscore b will be got as an input from the user while they call the function, and I can use the variables and manipulate the result. So instead of doing two constants, temp1 and temp2, 10 and 20, I can get inputs from the user and add it to the sum. Let's see how this works in Remix. Once you deploy this, you'll be again able to see that sum is 0. Now, in this set sum, previously we had just a button, but now it is asking for some inputs. What are the inputs? It's underscore a and underscore b, because there are arguments within the function here. Now, once you press on the drop down here, you'll be able to see these inputs separately. It's easier for you to enter the inputs. So let me give 20 and the second one as 35. And when I transact, what is going to happen is that integer underscore a will be assigned 20, integer underscore b will be assigned 35, and inside when I use underscore a and underscore b, it is going to sum these two and add it to the sum variable. So once the transaction is complete, look at the sum variable and you can see that the return value is 55 as expected, 20 and 35. So that is how you enter arguments inside a function. In general, whenever you are setting a variable, whenever you are adding a value to a variable within this Solidity, you call it as a setter function. So we'll say setter function, right? The next one we are going to look at is called as a getter function. Now, what is this getter function? Is that a function returns a value. Now, let's write the function in the same way, get sum, let's say, and it should also be a public variable, and you open brackets, close brackets to write the function. Now, Solidity wants to understand what you are returning in the function statement itself. For that, we might have to use something called as returns. This function returns something. That's what we are going to tell Solidity compiler. After returns, you open a bracket, and within this, you will give what is the type of variable you are returning to the user. Here, I am trying to return an integer, and hence, let's returns int. Within this, you can return any integer that you want. For example, let's return int 16, public c is equal to 20. So here I'll change it to integer 16 and we can return c. What this is going to do is just return the value of c to the user. Let's delete this, see what is happening. This should fail because that's how I have written it. I'll tell you why it failed and what needs to be done for it to not fail, right? When I click on get sum, the transaction is getting executed, but nothing is getting displayed here. Previously, when I click on, let's say, B, that is giving me a value here, right? I'm expecting that when I call this function is going to return the value of C and I will be able to see it here. Why it is not happening is because Solidity wants you to be specific with everything. Here, in this case, in this function, are you changing anything in the global variable? Global variables are these ones which we have declared. A is equal to 4, temp1 is equal to 10, temp2 is equal to 20. These are all global variables. Now, if you are changing anything in the global variable, let's say you are changing temp2 from 20 to 30, right? Let's say you are doing something like temp2 is equal to 30. This will change the value of temp2 from 20 to 30 in the program. And hence, whenever something changes in the global variables values, then you need to pay the gas fees to the Solidity programming language. Now, if you don't have anything to do with your global variables, you're not changing the data, then it is not a transaction at all, right? You don't need to pay gas fees. This doesn't go to the miner. You're just reading some data. The C is already existing and you're just reading what it means, right? Here, Solidity expects you to give a variable name or keyword called as view. So this function becomes a public view function. What is this name? Why is this view coming into picture? Is because you are not changing anything in the global variable, right? Now, whenever you give view and then deploy it again, now you can see that the function is going to return an actual variable. So this is the value that is stored in C, and that's what is being returned by the function. Without view, the compiler understands that this entire function is going to change something in the global variable, and hence it will not be able to return this as a view function and see it as a view function in the first place. Important thing to remember is that you need returns keyword. You need to specify the variable type that you are going to return. Also, if you are not changing anything in the state variable, you have to give a view function, view keyword as well. That is the first how you write a getter function. You can also return multiple values here. You can also return something like int, and you can return something like c comma a. But here you get a error because you need to enclose these within a bracket. So c will be the first variable type and a will be the second variable type here. Let's just see how this works as well before going to the next one. So you deployed it, and inside you go to get some. So once you click on get some, now we need to expect two variables from this. Once I click on this, it says int 16 is 20, int 256 is 4. So a is 4, and that's how it is returning that value to the user. What else can be done in the return statement? You can also assign the return values to a variable. Here you can say int 16 in the front end from the website that you are calling. You want this to be denoting a balance of a user, let's say, and the second one to denote the marks of a user, let's say. You can just assign values to this. So how does this reflect in your deployment and your front end? Maybe is that if you go to get some, previously remember that we only got the type and the value. Now it's gonna say integer 16, it's called as balance, and the return value is 20. And integer 256, the it's called as marks, and the value is 4. It does not matter what variable name you have inside the Solidity program. You can return it as anything else also. So just how I returned C as balance and A as marks, you can do that as well. So now you have understood how to return multiple variables and values, and how to assign the returned values to a particular variable itself. Now this can be accessed using your front end, and whenever you say okay, whatever is returned by the Solidity program, take the balance and display somewhere, it will be able to do it because you have assigned to the variable. That is the concept of having view keywords and returns keyword. Within that you will give all the variables that you are trying to return. Now, does a function always have to be either a getter function or a setter function? Not really the case. You can say remove this view and add a setter also here. You can just say a is equal to, let's say, 19. Once this is done, what this getsum is going to do is change the value of a variable and then return something else. It can either be the same variable or something else also. Now, let's see how this looks like also. So when you look into this, you can call this getsum, right? In which I'm going to expect a should be 19 and c should be the same thing which was earlier. Once you call getsum, because it's not a view function, it's not returning anything. That also needs to be noticed. But look at a, it will be changed to 19. So that is the differences between writing a setter function and getter function. Of course, this can be returned using an event which we'll be looking at later. But doing it together is not going to be a compilation error at least. So that's about the getter function and how to write that. Let me just remove this to make it a valid function. Now, a small change, a small difference between view and another function type called as pure exists. Now, just like you wrote this function, let me copy this, create a new function called as get sum 2, right? When I do this, and I'm gonna return two values, of course, as earlier, but here I don't wanna read anything from the global variable. I just wanna return some numbers I'm giving here. Let's say 20 and true. I wanna return a boolean. So boolean marks does not come here. Let's say attendance, right? So here what am I doing is, if you consider the first function, I'm changing the value of a global variable, right? It was sum was 0 before. I'm doing something to change the value of this sum, and hence it's not a view function, it's not a pure function. Both of it is not there because we are doing a transaction which requires a gas fee to be paid. Second, you are using a get sum function where you are reading the values of the variable. C and A are global variables from which you are reading the values, and hence this became a view function. The third option, where you do not even read anything from the global variables, leave alone setting some value, right? This does not set value nor read the value from the smart contract or the global variables, right? So in this case, view will become something called as pure, because this is a pure function which does not try to change anything in the smart contract nor read anything from the smart contract. This will be useful for using code reusability, having addition separate as a function, and you can call that from any function you want within the contract, etc. So these are the different types of functions that you can write. Remember, if you're changing the values of a global variable, you need not give anything other than public. If you are getting some values, reading the values of a global variable, view keyword, and not even reading or writing into the storage or global variable, you can give pure function. Next, what we are going to see now is to use the keyword called as memory. So there's a special keyword called as memory. We'll look at a scenario in which how you will use that memory keyword and in which scenarios it will be helpful. Now write another function. I want to set a string now. Previously we set a integer. Now I want to set a string to a particular variable. We have some strings here. Let's say I'll take name itself. I'll try to change the name of the person, right? So you can just write name is equal to, let's say, John or something. But I want to get this name from the user dynamically as an argument, just like we did here, and store it inside the name. Now, previously we gave integer the variable type and assigned it to a variable. Now, in the same way, if I do string underscore name is the one that I might have to give, and I'll assign name is equal to underscore name. I'll give spaces for readability purposes, but this shows an error, right? What does this error mean? It says data location must be memory or call data for parameter in function. We'll leave out the call data because that comes as part of the inheritance concept. But memory is something that we need to give for string variable types. Why does it expect that? In Solidity, as we have already seen, it expects many things to be very explicit. So it expects you to look at this integer. Okay, if you are setting an integer, so many space I will allocate beforehand, for getting the argument and executing the function. If you want to return something, you say integer 16. I'll allocate so many spaces in the memory so that I know what kind of variable is going to come in and how much amount of storage it is going to take. But in a case of a string, imagine you can give a single letter, or you can give a 5-letter word, or you can give an entire statement itself into the string. How will the compiler get to know that you are going to give these many letters or these many strings, these many characters into the string that you are inputting? These are dynamic inputs. The first time you call this function, you can enter something like a 5-letter word. The second time you do it, you can enter a large statement also. Now, that is the reason the compiler has to allocate dynamic memory into the memory. That's why for dynamic inputs, which can change in terms of the number of characters and number of storage required, you'll give something called as the memory keyword. Where all will memory be used? Probably a string and a struct. Struct can contain any amount of data, as you can see. This name, this attendance, this can change dynamically based on the input that the user is giving, right? That's why we'll give a memory keyword here. Let's see how this works as well. Deploy this, and if you go inside, we can see that setString is a function here, and I'm gonna give double quotes whenever I want to enter a string here. You can choose not to, but it's always a best practice to give strings inside double quotes. So the first time I'm gonna do this, let's say I'm giving a 4-letter word called John and set the string. The transaction is complete, and if I look at name variable, it's gonna contain John. The second time I call it, it can be a large text also. Blockchain is a decentralized network. Let's say, just set a string with this. Once the transaction is complete, again you go back to name. Name is gonna give blockchain is a decentralized network. So this is why we allocated the memory keyword. Otherwise, compiler would not know how many characters you are going to use in your input, right? So that's about our memory. This is the same scenario in which if you are doing a get string, let's say, this will be a public function. Of course, it will be a view function because I'm not going to change anything, but read some values from the variable called as name. So here, I'm going to return it to the user. So returns memory and then let's say name itself. So within this, I'm going to return the name variable, right? So this is how I take this. And you cannot give the same name. So let me call it, let's say, student name or something, right? Now, if I deploy this and look at the get string, where is my get string? Get string, it's going to give student name is Raghu. That is what is stored in the name variable at this point in time. Notice this memory keyword. That's the most important when it comes to this. Next one, we'll look at writing another function where we will see how to set values and get values for all of the other variable types that we have. As you know, we declared something called as a struct, we declared something called as an enum, a mapping, etc. In all of these cases, we were not able to assign this value directly when we declared it, right? So for example, when you declared a variable called as a, which is an integer, you can immediately assign a value to that. But in the case of a, let's say, mapping or even this array, we did not set that. We could have probably. In the case of a mapping, we were only able to create this variable. We were not able to assign anything directly, right? That has to be done only using a function. Of course, enum, we did that. We'll also look at another way of doing it. And we have a struct as well, in which we created a variable, but how to add these variables and values inside the struct is what we are going to understand, right? So let me create a function where we say set variables. Oh, it's not visible. Set variables, and then you do public. This is of course gonna change the values in the variables, and hence I am not giving it as a view or a pure function. Now within the set variables, let's look at what all we need to declare first. We'll go one by one. First thing, all of this integers, strings, booleans, bytes, and all of this we know how to set values to that. Now we have a dynamic variable called as students, which is an array. We already have Raghu and John here. Let's add one more name, right? So when you want to do that, you will say students dot push of a string, right? What string can we give? Let's say Alice. This will push Alice into the students array. And then what else do we have? We have a fixed array with 15 elements called as students2. Let's set students2 of, which means square brackets, and inside this you will give the index. Remember that an array starts with 0 index, and hence if you want to set the first element, I'll give 0 is equal to, this is also string, and hence I'll call it Raghu. It is not always necessary to push something into the dynamic array, right? You can also, students of, let's say 0, 1, 2 has already been set, and now let me set 3 is equal to something like Bob, right? This is also another way in which you add the new elements into the array. Only difference is push adds it to the last element, whatever it is. If there are 4 elements, it will add the new input to the as the 5th element. This can access a particular index and change that variable, right? So that's what these two differences are. And you'll also do students of 2 is equal to 0 is equal to Raghu. So students 2 is a fixed array in which the first element I am setting it as my name. Same goes for integer, so I am not getting into that. We'll look at the length probably in the another function maybe. And then we have mapping. Mapping has a variable and it has a key and value. Now the variable name is called as map and the key is a string, value is a boolean here. So let me open a square bracket and give, let's say someone, Barack Obama is equal to true, because the value is a boolean variable. So whatever is the key will go within square brackets here, and whatever is the value will be assigned to it. If you want to access this, you just give map of Barack Obama and it is going to give you the value associated with that particular key, right? What else? We have mapping, and then enum. We know that we can create cities public C1 and then cities dot Los Angeles or San Jose. Now you have a struct. Struct is important to understand how to set it up, right? Now what have we created as? We have a struct called a student, and using that as a variable type, we have created something called as student1. Now student1 is the first row in your Excel sheet that we looked at. So I'm going to create the first row, which means I'm going to give a name for the student1, attendance for the student1, roll number for the student1, and marks for the student1, right? Remember, name is string, attendance is boolean, roll number and marks are integers. So to do that, I will say student1 dot name is equal to, let's say, same my name, and then student1 dot attendance is equal to true, let's say. Student1 dot roll number is equal to whatever 34, and student1 dot the last one was marks is equal to 25, right? Once I said this, all of these details will go into the student1 variable, right? If you look at earlier what we had for student1, it is all the default values. String is blank, attendance is false, etc. So it will change those values in the struct itself. Now we have another method to add the variables to the struct, right? For that, we need to first understand global variables versus local variables. What is this global variable versus local variable is that these variables that we declared outside the functions but inside the contract is accessible by all the functions that you write within the contract, right? Now, when these variables can be accessed inside the function and you are storing something in the variable, for example, if you store temp1 equal to 10 temp1 becomes a global variable and that is stored inside the blockchain itself. When that is happening, you need to pay gas fees to the blockchain itself. Now, whenever you need a temporary variable, that is kind of swapping kind of an algorithm or anything, you need some variable to store temporarily some data, a winner or a sum or anything, which will be accessed by you later inside the function itself. You don't need to access that variable, a temporary thing, temporary storage, outside of this function, let's say. Those things will be called as local variables. Let's look at a function to see where this local variable can be used. Let me call this function as swap, right? I'll give something called integer underscore a, or let's say we'll take it from the global variable itself. Let me swap 10 and 20 in temp1 and temp2, right? So this will be a public function and a view function because I'm going, oh, it cannot be a view function because I'm going to change the values, of course. Go inside. If you remember swapping, right, we cannot do it without a third variable. Yeah. So I'm going to create a new variable called as integer swap temp, right? This integer swap temp has been declared within the function itself. Whereas if you see C, A, name, this struct and everything has been declared outside the function. Hence those become global. This integer swap temp becomes a local variable. Now I can say swap temp is equal to temp2. The temp2 value will be added into swap temp. Now temp2 is equal to temp1, right? Take temp1 value and store it in temp2. Then I'll do temp2 is equal to, oh no, temp1 is equal to swap temp. Does this do the swapping process for us? But after the swap is done, I don't need to access swap temp at all, right? That's the reason I made it as a local variable. Remember, you don't need to, no need to pay gas fee for a local variable, right? That is how you can use these local variables declared and given a value, given a temporary value within the function itself. So with this concept in mind, let's see the other method in which you can add values to the struct. You can now say struct, which is a student, right? Let's say memory, because as you remembered, memory keyword has to be given for dynamically added values to the variables. So struct memory temp student, I'll call him, is equal to a new student. Okay, new student, right? Here I can say the name of the student is, let's say, again Raghu, right? Then I can give the attendance of the student is true. Unexpected. Okay. Parse error, expected comma, but got this. Okay, it should be a comma then. What's happening? Oh, okay, I got it. Not an issue. As you write, the error will go off. Not a worry at all. Right. So name is Raghu, attendance is true, and then you have roll number, which can be given as 25, let's say, and then you'll also give you marks. Marks will be 99. Let him score well, right? And once you do this, you'll also give a full stop. So what have I done here? Ideally, is that I've created a temporary student variable because I declared it within the function itself, added all of the details into the temporary struct I created, right? Now I can do student1 is equal to temp student, right? So this will help me create a new struct also. You can either access the variables like this or using this manner, right? So to just show you the difference, let me create 3 students, right? So we can see all the methods are working, right? Student 3. So this, let me set it to student 2, right? There is one more method in which you can do the same thing. I'll do student memory, which means I'm creating a new temp student again, right? or I can actually access the same temp student because that value has been assigned to student 2 already. So let me do that. Temp student, right, is equal to open and close brackets, go inside this, and you can just enter the values in sequence, right? You can say John and then true and then 60 or 36, let's say, and then 80 marks. Yeah, you can do this, and then you'll be able to add student 2 is student 3 is equal to temp student now, right? So this is how you create the other method. Let's look at the difference and or the error that is showing here, right? Relevant source paths here and span across multiple lines. That's right. So okay, let's remove these spaces. Probably it works only with the flower brackets. It is all about looking at the error, understanding it, and then doing things, right? So type tuple is not implicitly convertible to struct, really. Okay. So what happens here is temp student is equal to a new student structure, and then you will say a tuple, right? Yeah. So I do not want to edit this off and give you a sense of doing everything perfectly. As developers do mistakes, you will be notified by the compiler, of course, and you should be in a position to clear those errors, of course, right? So you need to create this. Most of the time, people do forget this, as I did now, right? But this is how you create a temporary student in a different manner. You can just give literal strings in the same order, right? So that it goes sits into the variable. Now it's time to check whatever we have done here, right? So first we'll deploy this, and before I go to the set variables function, I'll look at the swap function just to be sure that it has worked, right? So what is our temp1 now? Temp1 is 10 and temp2 is 20 as we declared. Now when I call swap, it's going to be just the opposite. So now if I look at temp1, it's going to be 20, temp2 is 10. But nowhere here you'll be seeing this swap temp because that's a local variable. It does not have scope outside the function itself, right? Next, we'll set this variable and check out each of the values if it has gone properly. Now, set variables is done, right? Debug the transaction, invalid opcode. Why is that? Okay. Set variables, invalid opcode because temp student has been set to this. Global variables, all of it looks good. I don't see any compilation errors also. So if you look at this, this is just the XPDX license. That's not a problem, right? Do we have enough gas price? Yes, we do. And deploy again. Once you deploy, if you click on set variables, execution might have thrown an error. Let me take a look at that. Okay, yeah, got what this problem is. So if you look at this students.push and students of 3, these two do not go hand in hand, right? Okay, that's a mistake from my end. So let me just comment it out the second line, or you can keep any one of those, not an issue. And now I'll redeploy this. Okay, once we do this, we can see all the variables that we are setting up. Let's see if it works. Once I do this, because I removed that second line, the transaction is complete. You can note that from the tick mark that you get here, right? So what all are we setting here? Students.push of Alice. Let's go to the students array. Look at the first one. It should be Raghu. For second our variable is John. The third one is Alice because of this push that we are doing. Now students2 array, if you go to 0, that's going to be Raghu because we have set it up here, and map. So we'll just copy this, and if you go to the map variable and give something called as Raghu, let's say, that is going to be false because the default value is set for all the keys, right? So instead of this, let me give Barack Obama, and this will be true because that is how I have set it here. Then you will look at student 1. which is name and roll number, marks, everything, whatever we set at here, right? Then comes student 2. If you look at this, you have Raghu, true, 25 and 99 as we have set it up. Student 3 should be John, true, 36 and 80, and it is John, true, 36 and 80 as expected, right? So these are the different types of functions that you can write and how to set up or add values to the variables inside a function. I hope you understood the concept of setter function and getter functions, arguments that can be passed in, view functions, pure functions, return statements. How can you assign variables to a returning value also? I hope you understood the memory concept also, as setting up of all of these variable types, the values to it. And also look at the global versus local scope of the variables and remember the differences between that we'll see in the next section.